So now that we understand what data is, right? So let's move to the second part. This is a data engineering, right? The second step of our staircase that we discussed example, right? So just I'm giving layman things so that it's easy for if anyone is completely new, they can easily understand. So let's say for data engineering, right? Imagine data is crude oil. Data engineering is refinement. You might have heard this word, right? So oil refineries. So what is oil refineries will do? They actually take the crude oil and refine it to extract different liquids, could be fuel, chemicals, etc., so that people can consume it for some reason. People can use it, right? So that is actually data engineering. So in a simple, very simple example, if anyone is still unclear, so let's say there is water, right? So if data is water, so in a reservoir, for example, you have a reservoir or a lake or whatever, pond, etc. This water is there, and this is your data. So how this water gets supplied to the users or consumers or citizens in cities? Through pipelines. So this is the role of a data engineer. So they build the pipeline to make sure that the data is the processed data, or sorry, collected raw data is processed for some purpose. Okay, so you need pipes, pumps, storage filters, tanks, and then distribution system. So similarly, in data side also, once it gets generated from, let's say, websites, mobile apps, payment systems, and customer service systems, Internet of Things devices, right? So someone has to move on and also manage. So that is actually data engineering. So the role of data engineer is to manage the data. So to move, to clean, write it over here. So to move, clean, manage, right? So that is the key role. Otherwise, if they have not managed it well, what will happen? Your data science, your machine learning, your deep learning, everything gets failed. Okay, so your dashboards will get break, everything gets failed. So that's why companies invest a lot of time and money on data engineering stuff. So so let's understand in detail, a kind of bit theory here. But after data engineering, I'll pick one example and I'll walk you through what is basic things of data engineering and then the data analytics and data science. So we'll do one exercise very soon. I know it's more of theory so far, but I hope the examples that I'm giving is making you all to understand the concept, right? So this is a simple example, a simple definition. So it's a lot of people confuse data engineering with the data science. So, so both are not same. So there is a relation between these two, but both are not definitely same. They are related, but not at all, same. They're different. So think of like this. Suppose you are building a road or you are building a highway, right? So this is the role of a data engineer, just to give a layman example. And data scientists and analytic professionals use the road to ride, to travel or transit. Right. So that is a simple, basic understanding of data engineering. So the data, you see, I have given a simple example. Data engineer never asks why are customers leaving. Churning means leaving, okay, from a product or service. So they ask, is the churn data accurate, complete, and delivered on time? Okay. So that means a data engineer is focused only on the data part, wherein data scientists will focus on the insight part, the insight that they are generating from the data prepared by the data engineers. Okay, so this simple example, I hope this is making you all clear, right? And please don't get confused between these two, data engineering and data science. And sometimes, I see people also confused with software engineering also. Software engineering is where a developer will build the front end application. An application could be, let's say, suppose Amazon.com, a website. So software engineer is the person who actually built that application. Could be web-based or offline as well, right? So that is different, not software engineering. Data engineering is completely on data. Okay, and this is not, we discussed about, this is not a data science and this is not data science. A nice to have, not a nice to have. Exactly. See, data engineering is a key thing. If they do not have, a robust data engineered pipelines, data engineering pipelines, whatever analytics they do, they don't work, right? So this is very important. Okay, what is the job? If anyone of you are really interested to become a data engineer, okay, so you can actually understand the exact role here. Every data engineer, what they do is they actually help in support in ingestion. What do you mean by ingestion? So once, let's say the ShopSpear example, once consumer enter into Amazon, I'm sorry, shopspear.com, right? Then he did some activity, immediately it gets captured through streaming way. All right, that is ingestion. Once it gets ingestion, how to define the schema and store it in server. So it should be, a server or a cloud. Okay, a physical server or cloud. So how to store it? Once they store it, it is not possible for machine learning or data science experts to use the raw data as is. They have to transform it. So what do you mean by transformation? It's not something you are doing any manipulation. It is you're kind of arranging in such a way that the data can be leveraged. So it's a transformation. I'll give examples for each and everything. Don't worry. Okay, then it should serve the purpose. Could be reporting, business intelligence, dashboards, machine learning, etc., etc. Right. So this is the key for a data engineer. So if you want to become a data engineer, this is one of my favorite role because I work with both data engineers, data scientists, analysts, AI experts. So this is the guys who actually make your job easy. If any part here could be transformation or the way stores, schemas, definition, etc. If something gone wrong, then whatever model you built, that is definitely business people will come and say that this model is useless, right? So that's why data engineer, the coordination between data engineering and data science is also important in the organizations. They have to coordinate, make sure that the rules and the validations that is set by the engineer is also approved by the data scientists so that the consumption will be meaningful. Okay. Oh, okay. This is one important thing. So ETL versus ELT. So ETL, you might have heard this one, like extraction, transformation, and loading. So one of the biggest shift earlier, we used to call as ETL. Now we are saying ELT. Why it is and so on, right? Last few years, it is actually so extraction, transformation, loading. Imagine you are preparing food at home. You clean the vegetables first, right? You cut them, then you cook it. So then you store whatever the curry that you are actually cooked. So that is ETL, extraction, transformation, and you're loading, you're storing, right? But why we're calling as ELT these days is you're extracting and you're loading and then you're transformation, you're transforming. This is like storing all of your groceries first, deciding later which meal to prepare. So which one is easy? Instead of focusing on only one thing, right? So if you put everything and then start decide, this actually reduce the space. Why this is becoming is popular is this is space issue. Okay, I hope you understand. I'll explain again. Let me take a simple example here. Yeah. So you extract it, right? Then you transform it, then you load it for analytical purposes. So here you have to store the raw data, store the transformer data, then create something like cubes or aggregated tables to upload into your base so that the analytics team will start consuming. So multiple times you're leveraging, I mean, you're utilizing the storage space, so which is very expensive, right? So to cut down that cost, these days, people are following on extraction, loading, and transformation. Okay, so this saves a lot of time and money. space especially, right? So this gives more flexibility. If analytics wants to, create a different aggregate tables, so I'll give this more, when we discuss about one data set in ML, right? Because not the raw data directly, you can use it for any modeling purpose or any analytical purpose. You have to do some sort of aggregations. So it saves time and money for the organization. So that's why they are focusing on extract, load, and transformation. Okay. So that's about shift from ETL versus ELT. You might have heard ETL earlier, but now it's gone. Like people are extracting and loading, then transforming based on the need. Okay, so it saves the storage cost and also flexibility for the users to transform quickly for whatever purposes, like could be ML or dashboarding, etc. All right. Anatomy of a data pipeline. Right? So this is bit interesting and no need to memorize but try to understand, the basic difference between each of these things, right? So this is the journey of each of what you call as every piece of the data that takes. So think of it a parcel delivery service, right? Suppose if a package you order something, right? So let's say Shopspeare, you ordered something and that gets delivered to your house. So there is a sequence, right? So first they collect it and then transportation, then they store into a nearby warehouse, then they sort, and then they deliver it. So just apply the same example to your data also. So what they do for ShopSpear, they collect the information from different sources, websites, clicks. I'll write it here. So website, clicks information, everything, reviews. So different sources you capture. Then you collect this data for the ingestion purpose. The storage, so we save on some cloud, could be AWS or Azure or GCP, some cloud you store, right? So then you do cleaning and preparing for your analysis. So transformation is nothing but you clean and prepare, maybe arrange in a proper format or a proper structure so that people can start consuming it, right? So this is the data pipeline. So one pipeline or multiple pipelines based on the way how organization structures the data. So this is how actually it works. So hope you understand the source, ingestion, storage, transformation, and service. Okay. So this is very important. You have to have clear understanding of what is data warehouse, what is data lake and lake house. I'll give a simple layman example so that it will be in your mind forever. So data warehouse, just think like as we're using the words called lake house, let's use a water example. So just a water bottle. Suppose if you're purchasing a water bottle, packed water bottle, that is data warehouse. That means so raw water somewhere stored. The organizations, let's say water bottle companies, they take that water and they refine, they clean it and they pack it in a bottle and they sell it. That is data warehouse. That means so your organization's data stored somewhere and you are cleaning, or someone else, a vendor might be cleaning and keeping it ready for your consumption, right? So that is your data warehouse. So Snowflake is one of the best, tool, I could say, in recent times. The tech stack, the AI applications, Snowflake, Cortex, different applications are there, wherein you can use AI, GenAI stuff also for your data querying. So that is data warehouse, a cleaned data ready to consumption. If you are storing in a warehouse, it's called as data warehouse. All right. So then the second one is data lake. This is your actual lake. So, could be from rain or could be from, different ways or different streams. So water is coming and storing here, right? So different sources of data is coming and storing. So the, the raw and unprocessed data in one giant bucket. Okay. So Amazon S3 is one of the powerful example for data lake. So most of the top companies, top tier one, tier two companies, they use Amazon S3, AWS. We call it as Amazon Web Services S3. S3 is the storage name actually. They have given the S3 name for the storage. This is data lake, a raw and unprocessed data. Wherein lakehouse is basically you have your what you call data lake, right? And on top of this data lake, you build a lake, lake house. This is just to give a layman example. Imagine you have a lake here, then you are building a water plant here so that the water from this lake, gets through this plant and clean and ready for consumption, right? So Lakehouse, Databricks is one example. Apache Iceberg on S3 is another example. These are the tech stack people use it, to store, the raw data directly from the lake to clean and make it ready for the consumption, right? So please don't get confused if anyone is asking these questions during interview. Data warehouse, lake data, lake and data lakehouse. The data lake is the actual lake, the complete raw data to store whenever you are storing. That's called as data lake. S3 is one of the example. Lake house, if you're putting some refinement, some rules, some validations, and then make it ready for the consumption, that is called as lake house. Then whatever you have from your lake house, if you are putting something like a water bottle or some small aggregated cubes for small analytical purpose, different functional requirement. For example, you have lake house, then there is one data warehouse, two, one, two, three, four different data warehouses you are building. This is to use marketing team. They can use it for purpose of marketing activities. This is sales team. This is R&D. This is compliance, etc. So if you are specifically, designing some cleaned data and storing on somewhere, could be Snowflake, etc. It's called as data warehouse, right? I hope you clear on these things. Make sure be mindful when you are using the terminology lakehouse, lake versus data warehouse. Okay, so the Mendelian architecture. So this is the architecture that most of the companies, they follow when they set up their database, right? So after now, what is, data collection, how data gets collected, whether it's a streaming or batch processing, what are the different form of data that gets stored like warehouse, lakehouse, etc., the respective tech stack, etc. But this architecture, right? So you have to keep in mind how data engineers basically set this architecture before the data is ready for you to start using machine learning. So we call as bronze layer. This is raw data where whatever the clickstream, in our example, ShopSpear example, clickstreams data or orders data, reviews, etc., everything is dumped into your lake, right? So unprocessed data. So as it is arrived. Now after that, there is this silver layer wherein validated data. So what is the meaning of validated? I've already discussed. I'll again give a couple of examples. So for example, if there is a column called age, so the age should be 18 to 99 or something, some number, right? It should be 18 to 99. It should not be like 5 or 2 or 125 like this. This is not a valid. Similarly, gender. Similarly, dollar sale value. So dollar sale value also should be a number, right? It could be 0 to infinity, right? Sometimes it will be negative also because if a consumer is returning the product, it will store as -$2 or something. So there should be a number. It should not be like, a television or a mobile or something like this. No text. So this is one simple validation rule I'm telling you, right? For age, gender, sale. Similarly, if there is a text called, the product category, it should be text, like saying that electronics, right, or mobiles, or take some text, some category name. It should not be numbers. So these sort of rules set by the data engineers to the pipeline so that it gets through those pipelines using could be Python or PySpark or any or Scala, any programming language you can use, any big data processing language you can use. Hadoop a bit outdated, right? Hive and all, but now right now PySpark is very powerful, right? Python is also. So, and Snowflake, these kind of warehouses wherein people get used after the silver layer, right? So those sort of validations can be done. This is cleaned, validated. Okay, schemas we discussed, right? Whatever schema is required for marketing function, whatever schema is required for operations guys. So those sort of schemas they define and the respective joins are applied. So join, if you want to, understand more, join is nothing but so you're bringing multiple tables into one table by joining through one unique ID. Could be customer ID, right? Or a product ID, etc. Okay, so I'll try to give this simple example, especially when we do machine learning, when you bring multiple tables into one before you run machine learning algorithm. So that is silver layer. The last one is the gold one. So this is also called as golden ID. The golden ID is the ID which is cleaned and the validated ID so that you can map all of your table through that ID. So this layer is a business ready layer wherein you can directly start applying any algorithm or analytics or what you call machine learning, etc. Okay, so in our example, Shopspeare cleaned orders with unified customer ID is the one which is golden layer table. Okay, so this is very important. The architecture, how organizations design is first the bronze layer wherein the raw data get dumped right into a lake house. Then there is a silver layer. So they put some rules and validations. Then it is a gold layer where any function, business function can start consuming it. Right. Just a quick thing on storage format. We are not going much deeper into these topics. This is important for a data modelers. Okay. So why this format is important? Imagine your data today, you have like 100 MB data, and tomorrow it is becoming 1000 MB or, some GBs, and later, after a few months, TBs, terabytes. So if your data is growing, data is becoming large, then your structure, like, the rows and columns, if you add millions of rows and more columns, this is not a really valid for your analytical purpose, right? It takes a lot of cost, storage cost, so time also. So Parquet is one of the popular, in today's data format, one of the most popular format, which is like think of like a file cabinet, right? So you have so many files here. So you don't need to go through each and every file to understand what the content inside it. Just for analytical purpose. Okay. Instead of reading everything, you only read what you need. So quite similar to that. Parquet is the file format, helps you to store in a different way instead of a row. It stores by column, all right, which is faster for your analytical queries. So there is way in Python or PySpark where you can, query your Parquet format data for your analysis, right? So also you can build data lake and, Apache Iceberg on top of your Parquet format files so that your analytics will become more faster. Only two things like time. So you can do things faster and storage cost also be reduced. So that is the importance of this storage format. For AI, just to have a basic understanding of what is storage format, what is Parquet, and so on. That's it. There is a version control, reliability, and management of the schemas, etc. stuff will come, but that's a data modeler's role. So you don't need to worry about, no need to spend much time on those things. Okay. Orchestration, who runs what and when. So why I picked up this analogy is right. So this is a simple example. Imagine you have 100 musicians playing at the same time without a conductor, right? So he is a conductor. So it becomes chaos, right? So data platforms also face the same challenge. So one pipeline must run. We'll say there is a validation rule. So this must run. There is a ingestion, some ingestion, and then one validation, then some ingestion. So one pipeline must run before another. One data set depend on another one. Suppose you are processing 100 data sets, could be click streams, could be orders, etc. Right? So someone must coordinate everything. This is called as orchestration. This is very, very important. And if you want to become a data engineer, so you have to learn the tech stuff in Airflow and Daxter. So this role orchestration is just like a conductor in a concert, music concert. All right. So this Airflow and Daxter, these decides what run. Of course, the data engineer will set what runs, when it run, and what happens if something fails, what happens if a job gets delayed, right? Without orchestration, it is not possible to manage the data platforms. So if there is an issue in one data pipeline, right, your entire pipeline will get broken, and then it impacts on your machine learning models and deep learning models, everything. So it will impact your business insights as well. So that's why this particular part, right, when you're setting up the pipelines to run your data engineering stuff, it's very important to have a proper orchestration. All right. So now let's look at some common tools used in modern platforms, right? So for ingestion and transformation, and also for streaming. So ingestion, so Fivetran, and there is one more called Airbyte, and then DLT, data load tool. So these are a bit popular. So think of these like a data movers. What they do, they move the data from one place to another place, means one form, one storage space to another storage space with some meaningful. All right. So this is the way how the ingestion is happening, whatever could be streaming or batch. These guys, the Fivetran or Airbyte will help you to do the ingestion stuff. Then comes the transformation, right? So transformation data build tool is one of the popular. I mean, you can actually run through SQL. Think of DBT as a business logic layer, right? So it converts the raw data to whatever the rules that you apply or meaningful business data set. And then finally, we have, no, before that, let me talk about this one, this lineage, right? So documentation, testing, lineage, and deployment, everything happens here, the transformation part. The lineage is nothing but, so you have your raw data, and then you have your final, let's say, golden layer data. So it go through different transformations, means validation, some transformation. When I say transformation, for example, there is a time to time, right? Every day, let's say there is a day when 10 transactions happen for a customer ID. So if you want to prepare a customer ID level data, so you put some transformation, some aggregations, some business rules to, transform some numbers or some labels into meaningful business standards, right? So all the things, whatever journey it go through, right? So it creates a map so that if you go through that lineage, it will help you, it will give a clear picture of from raw data to what is the output that you can see. So it went through different phases, rules, and etc. And not only one table, maybe a multiple table can be arrived in the final so that everyone, the user, based on their need, they can leverage this data for any analytical purposes. So that's a transformation. This is very, very important. You provide for data science or the AI experts to have a clear understanding about this lineages. You have to make sure that you pick the right data set for your model. Otherwise, the insight, how you're interpreting, will be in trouble. So that's why this is very, very important. Then the streaming part, right? So streaming like Kafka and Spark, these are the two popular tech stack, I would say, tools which helps in streaming, and these they enable real time systems. Instead of waiting from tomorrow, you make your whatever rules can run through streaming. The moment the customer clicked something, so this gets through your pipeline and clean the data, and it goes and stores into your final data set. Okay, so this is about ingestion and transformation tools. Okay, so now let's discuss whatever we learned in last few slides, right, about data engineering. Let's put on this for our example ShopSpear, right? So this slide shows the complete pipeline for ShopSpear. So customer activity that is capturing through Kafka ingestion. So the event streaming, we discussed different sources, right? One is the streams. So once you get this ingested through your Kafka, the raw data lands in the bronze layer, right? So then the DBT, so once it has bronze layer, the DBT data build tool transforms it into trusted silver and gold data sets, right? So Dagster is the guy who actually orchestrates. So you use Dagster or an Apache one to orchestrate your pipelines, right? Once you have this streamed data, stored in a bronze data lake or delta lake, and you applied proper transformations, then you prepared your golden standard data sets. And you know what are the tools here? So Kafka, right, and DBT, Dangster. And then what finally you're getting is the golden standard quality data. great expectations, we say. Because this one, once you have the data, this is going to use by your data scientists for any ML or any AI stuff, right? So now if you notice something important here, nothing magical happened, right? We simply build the right foundation. And that's the biggest lesson of data engineering. Before AI can become intelligent, the data platform must become reliable. That is important. So the data is validated and check the quality, all the 6 dimensions, what we learned, and then it is reliable. So you can trust this data and go ahead and build your analytics. Otherwise, your insights won't be any making sense for your business. Okay. So now we discussed about data and data engineering. So 2 layers. Now we are comfortable. Like I hope you got a strong foundation about these two. Now we're entering into the key thing, that is data science. Let's move on.